Now that you should be comfortable constructing truth tables and assessing individual sentences, we're going to move on to using them to assess the validity of arguments. The best way to explain this process is by showing you, so in this video we're going to work through a few examples. The first argument we're going to look at has the premises if P and Q, and the second premise Q, with the conclusion P. We're going to set up this truth table with the premises first and the conclusion at the end. Even though one of our premises and the conclusion are technically already on the table in the first two columns, it's better to repeat them in this order so you don't make mistakes while doing the assessment. For this example, each sentence in the argument has only one column because they aren't complex sentences. But if they were, you'd use the breakdown video I showed you on the earlier examples in the last video to get their truth values. Let's start filling in this table, starting with the first premise. Premise 1 is a straightforward material conditional, so we're just repeating that characteristic truth table. I'm sure you're already tired of hearing me say this, but it bears repeating. A material conditional is only false when the antecedent is true and the consequent is false, as shown here on row 2. Now we need to fill in the rest of the truth tables, which is just copying the truth values for Q as the second premise, and then copying the truth values for P as the conclusion. With the completed truth table, we can now assess whether this argument is valid. Remember, an argument is valid if and only if it is impossible for all the premises to be true and the conclusion to be false at the same time. So what we're looking for is a row on the truth table with true premises and a false conclusion. If we can find one, the argument is invalid. If we can't find one, it's a valid argument. So let's start by highlighting any rows that have all true premises. For this argument, that's row 1 and row 3. Now we check the conclusion on those rows. Row 1 has a true conclusion, so it's not a problem. But on row 3, the conclusion P is false. Row 3 shows that it is possible to have all true premises and a false conclusion at the same time, so this argument is invalid. When doing homework, I recommend you highlight or circle the row that shows an argument is invalid, as it makes it clearer to the grader what you're basing your answer on. Let's look at another problem. Here we have the premises if P then Q, and as the second premise, it's not the case that Q. With the conclusion, it's not the case that P. So we'll go through and fill out the truth table here a bit more quickly. Same characteristic truth table for if P then Q. We're going to flip the truth values from the second column that contains Q to get the truth values for the premise, it's not the case or not Q. And flipping the truth tables from the first column that contains the truth values for P for the conclusion that not P. Now we need to identify any rows that have all true premises. On this table, that's only row 4. And the conclusion on row 4 is also true. So now there's no row with all true premises and a false conclusion. That shows this argument is valid. Let's quickly go over one last example. The premises are P and Q, and the second premise, it is not the case that Q. The conclusion here is not P. So let's fill in the columns of this truth table. We have P and Q, that's just the characteristic truth table, true when P and Q are both true and false otherwise. We have not Q, flipping those truth values for Q, and not P, flipping those truth values for P. Now we need to look for any row on which both premises are true. And there isn't one. On one row, on every single row of this truth table, at least one of the premises are false. And that's because P and Q and not Q are logically inconsistent. So what do we say about this argument? Is it valid or invalid? Well, because it's not possible for all of the premises to be true, it's also impossible for all of the premises to be true and the conclusion to be false at the same time. This is a valid argument. Remember back to the very first lessons in this course. There are two counterintuitive cases of validity. This, having a logically inconsistent set of premises, is one of them. The other is if the conclusion itself is logically true. So when using truth tables to assess validity, remember that an argument is only invalid if you can identify a row that has all true premises and a false conclusion. If the premises are never all true, like in this case, then the argument is valid. Also, if the conclusion is never false, if you always have a true conclusion, then that argument is valid as well. I know that doesn't make intuitive senses because we think of valid arguments as good arguments where the premises support the conclusion. But with the operational definition of validity, we do have those two weird cases. So that's all the content for this video. I will do a second video going over more examples, more complex examples. As always, I have recommended resources in the textbook and the course manual for further reading, as well as a series of practice problems you may want to check out for your own understanding. I'll make another video going over those practice problems. If you have any questions or need help, please don't hesitate to reach out or bring questions to class.